One of the greatest advantages to digital cameras is the instant image review, but we should use it with caution. The reason is the LCD is built to give us a good preview under a range of lighting conditions, and because of that, it may not always be the best judge of exposure. I like to think of the preview as a Polaroid. Check for the things you may have missed while looking through your viewfinder, or check the lighting or the amount of motion in a scene. It's a good time to see if there's branches or a telephone pole coming out of your subject's head. Here's an example. I was photographing these waves at the beach, and I really wanted to get this long, drawn-out look to the waves. I wasn't sure whether that was going to occur at a half of a second, or 1 second, or 4 seconds. So I took multiple exposures and realized that 4 seconds looked really good. Through the zone system, I was able to meter and get a good exposure. So now it was just simply a matter of taking multiple shots and picking from the best one, knowing that my exposure was correct and the amount of motion that I had was correct in each one of those frames. Similar thing here. Photographing a parade. I wanted the exposure to be long enough to allow motion to come through the paraders, but I wanted the crowd to be as still as possible. So after experimenting with several different exposures, I came up with about a half of a second. And the crowd was still enough, and the motion in the parade was enough to get the idea across. Now I was able to shoot multiple exposures all at a half second. Good exposure should be accomplished through metering, rather than looking at the back of your frame. Check your exposure by looking at the histogram. So, what is a histogram? Well, it's a graphic representation of the tones within a photograph. So what exactly does that mean? Well, it means that the tones are distributed from right to left according to how bright or dark they are, and from top to bottom by how much of that particular brightness is within the scene. So in this image, we've got a fair amount of average blue, and most of the histogram is clumped in the center from right to left. This side represents the highs, or the brights. This side represents the darks. The height of the histogram here shows us that there's a lot of blue. In the snow scene, we mostly have bright values, and so the histogram is clumped towards the right-hand side. Spike in the center here shows us that there's a lot of information in that particular brightness range. With these dark values of this burnt forest, we can see that the histogram shows us all the information is to the left, which means there's no midtone values and no highlight values at all. So the higher the histogram spike, the more of that value there is in the scene. But I don't find this as useful because we can simply look through our viewfinder and know, wow, there's a lot of snow in that scene, or there's a lot of burnt forest. So I don't concentrate so much as on the height as I do on the distribution from right to left. The placement of the spike from right to left determines the tonality. That's important for us to know. So we can see here as we pull out a gray ramp where these tones fall out. In this particular histogram, there is almost no zone 7s. We've got a fair amount of zone 6s, a fair amount of zone 5, a little bit of zone 4, and almost no zone 3s. So let's look at what happens as we place our values on our display. Your zone 5 ends up right in the center. When you open up a stop, this is what you get. Now notice, the histogram is always going to read the bright values on the right and the dark values on the left. Here, this particular display runs opposite of that. So if your display runs like mine, be careful not to confuse the two. When the hash mark is at +2, it's representing this part of the histogram. In the other direction, your zone 4 and your zone 3. This is what we really have to be concerned about. Anything that falls off the histogram to the left becomes pure black with no detail. Anything that falls off the histogram to the right will be pure white with no detail. And as I mentioned before, this is the area that once we lose it, we can't get it back. With a little fudging in Photoshop, you can bring some of this detail back. So, if your histogram looks like this, then your shot is going to be underexposed. And we have to realize that's what's happening is that right here, the histogram really is finishing. And all of these values here are going to represent the deepest blacks within your frame. Conversely, if you overexposed your frame, you would need to know that the histogram is going to finish, and these bright values are going to be represented by overexposed areas within your frame. But you know how you would expose this photograph. You'd simply meter the midtones, put them at 0, and then meter your highlights and check them to ensure that they're not blown out. And if you give your image a good exposure, you end up with a good histogram. Notice our highlights are not blowing out, and our shadows are not blocking up. But we might not always get this lucky. Sometimes images have such high contrast that you can't contain them. Here's an example. In this image, with this current exposure, our highlights are blowing out and our shadows are blocking up. If you gave it more exposure, sure, you get some more detail in your shadows, as proven here in the histogram, but your highlights are still blowing out. And if you get the histogram reading properly, where our highlights are protected, we've got plenty of detail there, your shadows are still underexposed. Now, you can fix this in Photoshop with a little bit of fudging, and sometimes you're going to need to do that. But if you have the option, you're better off taking multiple exposures. So you would take this exposure to ensure that you've got the highlight detail, and then take this exposure to ensure that you've got the shadow detail, and then you can blend them together in Photoshop. The reason for that is because fixing your image in Photoshop can lead to decreased image quality. And heavy correction may cause an image to posterize. I'll show you what that means in just a second. And the reason that it posterizes is due to the way our camera's sensor captures information. Let me show you. Here's our histogram and the corresponding tones as they lie out. Now, the moment that you make an exposure, the histogram is divided up into these sections, and they're not equal. And what will happen is that this area of the histogram, all of these pixels in here, will all record 2048 levels of tone for each pixel. That's a lot of tones, and that leads to nice gradations. Down around zone 4 and 5, they're only going to be able to capture 1024 levels of tone. That's sufficient. But down around 3, notice that these sections all capture very, very few amount of tones per pixel. You start messing with this area in Photoshop, and you're likely to get banding. So, when you take a histogram and you have this information in here, you can fix it, you can bring some of it back, but look at what the histogram looks like. This is called gapping, and it represents a lack of information. There is literally no information where these whites go all the way down. That will manifest itself in a print by showing harsh gradations between tones, or between black and white values, or even in skin tones. You may not notice it on a screen, but if you make a decent sized print, it's going to be much more readily visible. Here with this shot, we notice that the aspen trees are somewhat underexposed. And here's a better exposure. Notice that our values are sitting up higher on the histogram, closer to the right-hand side, but yet nothing is blown out. Now, I could go back into Photoshop and brighten both of these images and add some contrast to make them more appealing. Look what happens to the histograms of each. The histogram on the left is far more gapped because its information was sitting further to the left. The histogram on the right has some gapping, but not nearly as much. This is going to produce a much nicer print. Another example. In this shot, I made my exposure such that the sky contained detail. Down in here is very dark though. That's being represented by this section of the histogram. Now in Photoshop, I could go in and I could create a mask and I can brighten those tones up. And it would work. However, the corresponding histogram is going to show a lot of gapping down in that area. And that may become problematic when you make a print. So in the next section, I'll show you how to bracket your exposures and how to meter for those exposures so that you can blend these images together in Photoshop.